Hello and welcome to my lesson on long division. Long division is used for harder division problems when a person does not have a calculator. It can sometimes be used in real life if you're at a restaurant trying to figure out a tip, or if you're splitting a bill or something like that. However, in most cases, it is used in an academic setting when a teacher asks you not to use a calculator or it's not allowed on a test, whatever it may be. Long division uses DMS-BR. This is kind of like PEMDAS or GEMDAS, depending on which one you learned, where it's just an acronym for the steps of the problem, the order operations, which means divide, multiply, subtract, bring down, and repeat / remainder. I will get in the remainder later, as it's used when you don't use decimals. And remember to always check your work. This applies to any math, not just long division. However, in long division, it's very easy because all you have to do is multiply the quotient by the divisor. And those are two of our vocab words for today. Our vocab words are divisor, dividend, quotient, and remainder. Divisor is the number you are dividing with. You might have been taught that it's the smaller number in the problem, but that's not always the case. A lot of the time, but not always. Think about 25 divided by 5. So you hear that divided by 5. The 5 is the divisor in that number. The dividend is the number being divided. So 25 in that case. 25 divided by 5. So dividend divided by divisor equals the quotient. The quotient is the answer to the division problem. This is the same idea as a product and multiplication, or a sum and addition. Lastly, we have remainder. It's the last number that can't be divided by evenly. So this is when you're using decimals, it will always come out as a 0 unless it's a repeating decimal, but we'll get in that later. This is mainly used when you're not doing decimals, so we'll get into that later. I'll explain it. Anyways, let's get into the first example. We have 425 divided by 25. So over here, got divisor and dividend color coded just so you can see them at first, and we're going to do the problem right here. You will most likely see a problem like this. 425 with the division symbol, the 25. Sometimes like this, where it's over, the dividend is over the divisor, and this is also where fractions come in. As you divide fractions quite frequently, you just probably won't use long division. Alright, let's get into this. So the divisor, 25, will go into 425, but unlike most problems, you start at the beginning instead of the end. And that's a little weird, but it's just something that you'll get used to, and you'll understand why in a bit. So as per DMS-BR, divide 25 into 4 is 0. So this 0 is more of a placeholder, just so you keep everything straight. It's not necessary, but I'm going to write it for the sake of this. Next on DMS-BR is M. So multiply. You take this number that you just got and times it by the divisor. So 25 times 0 is 0. You put it under the 4. And you subtract. It's the third step. 4 minus 0 is 4. Now we bring down 2. 42. Now we repeat, as the division is not over yet. So 25 into 42 now goes once. 1 times 25, 25. Subtract, and 5 doesn't take away from 2 very easily, so we do normal subtraction, get 17, and 25 doesn't go into 17, so we bring down the 5, and we get 175. Now we repeat again, 25 in the 175 goes 7 times, and that equals 175. 0 for subtraction, and we're done. The answer is 17. The quotient is 17. The 0 is technically the remainder. We will not be using it in this case, as you're never actually going to use remainder 0 even in cases of no decimals. I'll explain it when we do get to the decimals. So let's move along. Long division with decimals. I have 2 examples here because there are 2 types of answers I want to go over here. Or, sorry, 2 examples of one type of answer. We're going to be going over terminate decimals. So we're going to begin with 80 divided by 25 first, as it comes out a lot easier than 80 divided by 7. So 25 and 8, 0. 0, 0, bring down 8, you're back to 80. You can typically skip this step once you get down that 0, like a 0 is going to pop out at the beginning. 25 goes into 80 3 times. Multiply, we get 75. Subtract, we get 5. And we're down to here, 83 and a 5. But 25 doesn't go into 5. So we put in our decimals. You will place them here now just so you don't get confused later, as it's much easier now. So 80 is technically just 80.00, etc. So you can put a 0 after and it doesn't change the number, but it helps you get the answer. And we bring down the 0. So we get 50 down here. 25 goes into 50 twice, and it's even, as 25 times 2 is 50. That gets us 0 at the bottom, with technically remainder 0 as a reminder, and our answer is 3.2. This is considered a terminate decimal, as it just straight up ends. It doesn't repeat forever. An example of a repeating decimal is pi, but that's a different type of decimal. A repeating decimal is like 0.333 repeating, which we will get into in the next example after this. Alright, 80 divided by 7. 7 goes in 8 once. And for any of these problems, you can pause, go back, and re-listen or think about it again. Whatever helps you learn. I'm giving multiple examples, as that's the way I learn, and I hope it helps you. Okay, so 7 to 8 once. 1 times 7 is 7. Subtract. Get 1. Bring down to 0. You get 10. 7 to 10 is 1 again. Then 7, 3. 7 doesn't go into 3, so we begin the decimals. 0 down. Get 28, as 7 goes into 34 times. We get 2, another decimal. 20, that goes in twice. 4, 14. It's close to 3 times, but not as that. 6, and I would keep going, but this is a very long answer, and if you want to try to do this yourself, you can. Just plug in 8 divided by 7 into a calculator, and you will get 11.428571 4285743. That is very close to repeating decimal, I just realized. But that is technically a terminate decimal, even though it is such a long number. And that is just another example, so you can realize that just because it's a long number doesn't mean it's a repeating number. Which, let's get into that now here. Real quick, if I were to end this here, as some problems would, 11.42, you could put remainder 6 here. So you would just put R6. Whoops. Yeah, that 6 is the remainder, and that's how you would answer up here 11.42 R6 if you were asked. In our case, you could put 3 R2 for over here, as that's completely accurate as well. But we are working with decimals, so I'm gonna ignore the remainder. On to the last problem. I put the 1/3 here because it is a repeating decimal of 0.33 repeating, and sometimes we forget that small numbers can create the same effects as big numbers. So in this problem, we are doing 385 divided by 3. So I'm going to quickly go through this for sake of time, as you know DMSBR, and you can pause the video, rewind, slow it down, whatever you need to do to understand this, and you have my commentary over it for anything that might be a little unclear. So let's begin. 3 goes in 3 once. 3 times 1 is 3. Subtract 0. 3. Bring down. 3 and 8 is 2. 6. 2. 5. I wish that looked like a 5. 1 second. I'm gonna just show the arrows real quick. 3 into 25 is 8 times. 4, 24. 1. So now we get into decimals. So I'm going to put the 0.0 after and put the decimal up here. Bring down the 0. 3 into 10, 3 times. 4, 9. 1. We get another 0. And we're back at 10. 3 times. 9. And now you see a pattern. 10, 9, 10, 9. And we're going to get 3 up here multiple times. Well, infinitely. So for this, we write 128.33. And to show that it's repeating, we put a bar over it, like a line just over the 3's, to show that it repeats unto infinity. And that's it. You are done with the problem, and the answer is 128.33 repeating. And like I said before, 1/3 comes out to 0.33 repeating. And I have found that, real quick, with the 1/3, sometimes you see it as 0.34, and this is just a way to make it not a repeating decimal and make it just easier to read and easier to really work with. However, it's not technically correct. So 33 is fully correct, but 34 is easier to work with. But anyways, I was gonna say, I've found that with dividing by 3, 6, 9, multiples of 3 in general, kind of mostly leads to a repeating decimal. Not always, of course. If you're dividing something that is divisible by 3, it's not going to be repeating. But if you take something that typically isn't divisible by 3, it will most likely come out to a repeating decimal of the same degree of a 1/3 fraction, 2/3 fraction, and 9 is a little weird along with other numbers, but 1 or 2/3 fractions are common, and 2/3 fraction is 0.66 repeating. Thank you for watching this, and I hope you learn a lot from this and are able to use it further as your long division develops.